here we go. The biggest difficulty you're going to run into as we get into volume is visualization. So when we were doing area between curves, if you were careful, you could draw some nice pictures to see exactly what you're working with. You could clearly see your representative rectangle. When we get into volumes, it ain't so easy. And I think that's probably going to be your biggest struggle. The math isn't too bad, especially after this lesson today. You'll be like, that's it? I can do that. But it's visualizing what these things look like that's going to be tricky. You're not going to have to draw pictures of these things. But for those of you that are visual learners and want to see what you're doing, you might struggle a wee bit. Okay, so we're going to find the volume of some objects using what's called the cross-section method. So we're going to stack geometric shapes on top of a plane, and those geometric shapes are going to form a figure, and we're going to find the volume of that figure. So in simplistic terms, if you think of a package of paper is a whole bunch of rectangles stacked up on top of each other, and when you get enough pieces of paper stacked on top of each other, all of a sudden, boom, you got a box. Or if you want to be technical, a rectangular prism. Okay? We're going to be doing the same thing, but they won't look so pretty. So it's not like we're going to do a bunch of calculus and then all of a sudden use that to find the volume using geometry. We're going to find the volume using calculus. Okay, and this will make a little bit more sense when we get into it. So, only two things. Number one, you should be able to find the volume using cross sections, and number two, you should be able to relax. We got like 1 week left, kids. Okay? I'm sorry?
Please don't leave school. I was really confused. I was very confused about what it was.
Spring break.
Yeah, I'm on the same page.
You okay now?
You're
with me?
I promise.
Are you relaxed?
No, but yes, I'm in there mentally though. I'll try.
You'll try. Okay. Sure. All right, here we go. All right, this is basically just a reiteration of what I already said. We have at least two other actually, there are three other methods, but because we're in AB, we don't have to do the third method. Because the third method is gunky. Okay, so you will be required to refresh a little bit of your geometry skills. I think at this stage you can all find the area of a rectangle, a square, a triangle, semicircles probably with a little bit of help for some of you. Trapezoids might have been a while, but I will help you refresh your memory as we move along. Okay, like for instance, how many of you remember how to find the area of an equilateral triangle? It's a good thing I included that in an example then, because your geometry teacher failed you. Some of you, I'm sure, remember it.
I got it.
There you go. Oh, wait. This will be fun. Hopefully this works.
Can't open it.
Oh, okay, here we go. So, we're going to take a figure on a two-dimensional surface, also known as a plane. We're going to use a circle. And we're going to stack shapes on top of it. And when we're done, we're going to have this cool 3D figure. Okay, so for this demonstration purpose, I'm going to use, what am I doing? I'm using squares on top of this circle. Okay, so first things first. We're going to click on that button and turn it into like a cool 3D thing. Okay, so that's still a circle, but I want to get some 3D action going there. And so I'm going to take and stack a bunch of squares on top. Okay, that's just 4 of them. This is calculus. How many squares do you think I'm going to stack? An infinite number of squares. Okay. So it's going to do something like this. Now notice when I start at negative r, negative radius, I'm starting with an infinitely small square. As I move towards the halfway point of the circle, I get the biggest square, and then it shrinks back down. So as that's sweeping for a third time, I want you to try to visualize in your head what that three-dimensional model is going to look like. Go ahead. Mm-hmm. And you're probably going to be wrong, but I'll show you. Looks like a hat? Well, kind of, if you're the Pope. It looks like that. So this surface here and the back is still a cylinder because it's based off of that circle, but then as we sweep to the other side, it's getting that curved spot across the top. There's no geometric formula for finding the volume of this. Okay. But I will show you how to do it. Oh yeah, look at that. I will show you how to do this using calculus. Okay, and this kind of gives you a precursor how we're going to go. So there's two components at work here. This is a circular base with squares standing on top of it. We can change either one of those components. For instance, reset on my second little guy, I've got a circle again. Again, do the fancy 3D thing. But now I'm going to sweep an equilateral triangle on top of that. Okay, visualize in your head what that 3D model is going to look like. And it looks like this. Doink. Okay, so that guy. Again, you see what I mean? You're not going to be drawing these. And if you are, there's something wrong with you. So don't. It's not healthy. Now, what can we change? Well, I could do isosceles right triangles. This one's kind of boring. I'll just show you. Isosceles right triangles. We end up with that weird looking thing. Okay? Looks like a door wedge. Or we could get a little crazy here and we can take a right triangle. Whoops, I probably didn't want to do that. Take a right triangle and then stack semicircles on top of it. Okay, like this. What's that going to look like? Well, there it is in 3D, and you see we get this cool kind of, not kind of, it's half a cone. It's just fun to watch. Okay. What you're not going to have to do is describe the shape, because that would be nasty. All you're going to have to do is find the area of this puppy. All right, so you understand where we're going. There's two things we're working with again. What base is it sitting on, and what figure are we stacking up on top of it? If you can find those two things, this will be easy peasy lemon squeezy. No. Okay, so how do we do that? Well, you'll see there's this nice little formula, and yes, the formula is just that simple. All I need to do is find the area of that thing that I'm stacking on top, and I use the integral to add up all those infinite number of things. So if I'm stacking squares, I need the area of a square. And I integrate to find the area of all those infinite squares that are stacked on top. Now you can imagine there's going to be a little bit more work to this and a little trickiness, but we'll get there slowly. Also, based on what we talked about earlier in the week, when we were doing area between curves, notice that we can work in both x terms or y terms. If it's perpendicular, if that representative rectangle or that representative shape is perpendicular to the x-axis, we'll be working in terms of x. If it's perpendicular to the y-axis or a horizontal representative rectangle, we're working in terms of y. We're going to focus on just x for a little bit. Okay. Questions so far? Seems pretty easy, yes? Hello, is this on? Testing. What, does this seem pretty easy, yes? Okay, let's see if I can destroy your dreams. Okay, so here's our first problem. We're going to use, a circle would be, we've seen circles already, so let's do something different. I'm going to use a region known as x equals y squared. What does that look like? Anyone? That goes really well on the recording, Conrad, thank you. For those of you at home, Conrad is saying this.
Yeah.
Did you swallow your tongue, or could you vocalize?
It's a parabola turned on the side.
Beautiful. It's a sideways parabola. Okay. By the way, it's a helpful hint. I'm sure you know this, but if you switch the x's and the y's, it's the same graph, just reflected over the line y equals x. We did that with points. Okay, and then we're going to stack on top of that rectangle. So the first one I decided to make easy in that I fixed the height of the rectangle. Okay, that's not going to change. On the examples that I showed you on that program, the height changes as you move along. This one, we'll keep it easy peasy lemon squeezy. Okay, so there's our region. As Conrad said, it's a sideways parabola. We're going from 0 out to 9. How do we know that? Because it says here x equals 9, and so it's that region bounded right there. I chose to use a horizontal, sorry, that's vertical. I chose to use a vertical representative rectangle, and I drew it over here at 9. Okay, so that's our base. Everybody good with me so far? We're going to stack on top of that base rectangles, so they'd be sitting up out of the board. To make your life easier, instead of trying to draw that three-dimensional figure, what you're going to do is draw a two-dimensional figure over on the side. Boom, there's my rectangle. You don't have to shade yours so fancily, but I've got some mad PowerPoint skills, so I'm feeling saucy. One thing I do like, however, is notice that big black line I put at the bottom. That big black line matches the representative rectangle from the figure. That will help you visualize what's going on. Okay, now here's the hard part. How wide is that rectangle? Well, I already put it in the picture. It's 2 times the square root of x. How do I know that? Well, if I pick any point on this curve, since I'm working in terms of x, it's going to be located at the point x comma the square root of x. And this goes back to what we did a long time ago. Any point on a function is xy, but this is calculus, so now it's f of x. Sorry, x comma f of x. What's f of x? Well, our f of x is written weird. It's written in terms of x, so I did a little bit of math in my head, which I think you're all with me on, and I took the square root of both sides. That's an important concept. Is everybody with me so far? Okay, so half of this representative rectangle is going to be the square root of x. That is the square root of x. I have 2 of them that make up the base of the rectangle, so that puppy is 2 square roots of x, which matches this. And to make your life very easy in the first time through, like I said, I fixed the height of the rectangle at 2. Okay, that's the hard part. Now the easy part, what's the area of that rectangle?
4 root x.
Say again?
4 root x.
4 root x. Yeah. Base times height. Did you really have struggles with that, or? No? Okay, we're good then. And then I'm looking at rectangles from where to where? Well, I'm starting at 0, and I'm going up to 9. Remember, when you're working in terms of x, you're looking for rectangles moving to the left and to the right. And like a lot of our other lessons, I don't really care what the answer is. I just want you to be able to get that set up, because I'm assuming that at this stage you should be able to do that antiderivative and find the answer. It is a numerical answer because we're talking, a positive numerical answer because we're talking about volume here. Okay. Before we move on to something more interesting, are there any questions? Or does this make sense? Or are you just going to sit there quietly?
Makes sense.
Oh, thank you. Excellent. That's 1 out of 28. We're good to go. It's enough for me. Let's move on, shall we?
We shall.
Okay, good. I got 2 out of 28. We're making progress. I just doubled our past score, so that's good. See if we can double it again, and that way we have an exponential audience participation. That's a math term. You know,
Really?
1 to 2, 2 to 4. See what I'm doing with that, Aaron?
Very common.
4 16.
Whoops, a little bit quick there. All right, let's do a circle. We're going to stack some equilateral triangles on top of each other. We did. You saw this in the little thingamajobber here. And so we're going to start with a circular base, so I get that. I decided to do this one in terms of y. No particular reason except the problem says perpendicular to the y-axis. If it's perpendicular to the y-axis, then I have a horizontal representative rectangle, which forces me to work in terms of x. Okie doke. Algebra 1 review question. What is the equation of this circle?
X squared plus y squared plus 6.
Did you know that, or did you read it off my slideshow?
Well, I saw it, but we know the radius.
Do we know?
Mm-hmm.
You could all do that, right?
Yes. Yeah.
Just checking. I don't want to assume anything. Sheesh.
You know what they say about assuming.
Yeah. Yeah.
For real.
I'm safe. Record. Okay. There it is. Oh, I solved that in terms of x. sorry, I solved that in terms of y. I solved 4x. Why? Because that was a joke. I didn't mean that. Why? Because I want to work in terms of y. How do I know I'm working in terms of y? Because I said earlier I have a horizontal representative rectangle. So, Faith, let's pick on you. Where is that point? Now, just for reference, that could be anywhere on the circle.
X equals 4? X equals 4?
Nope. Anybody else?
X comma.
Yes, but we're working in terms of y. So I'm going to give you this.
Should we change it?
Comma y.
Oh. Oh, so 6 root of 16.
Root 16 minus y squared.
Okay. Any point on that circle will fit into that mode. If we were working in terms of x, it would be x comma root 16 minus x squared. Make sense? Okay. So if I know this, how long is that?
Root 16 minus y squared.
Good. Which makes this whole thing in blue 2 root 16 minus y squared. Are we okay with that? Good. If it was a square, if I was a nice person and I said let's stack squares on top of that thing, it would be a lot easier. I'm not a nice person, and so I decided to use equilateral triangles. Boom, there's my equilateral triangle. Mason, your turn. I don't know what kind of riffraff you had for geometry, but how would you find the area of that equilateral triangle? Because if you can help us find the area of that equilateral triangle, we're pretty much golden.
Well, it would be the base times the height, which should be,
He's not a puppet, leave him alone. I think we all see where you're going with this, right?
yeah.
Find the base, calculate the height, maybe if you're feeling fancies in your pantsies, you can do some 30, 60, 90 triangle stuff.
Yes.
Yeah. However, I'm going to give you an alternate method, which I hope your geometry teacher showed you at some point in time. I know I did my due diligence. This is the formula for an equilateral triangle. How many of you have honestly seen this and maybe don't remember it, but you've seen it somewhere? Once again, the educational system just fails to provide the necessary tools that you need to succeed in life. I would drop out and get a job at Walmart. A lot of opportunities for advancement. You get a nice blue vest, not far from home, hours are flexible.
One of the scanners too.
You get a scanner. Yeah, well, depending on, I mean, you might just be a greeter. I see you as a greeter, Adrian. I walk in the Walmart. Can I help you find something today? Well, yeah, I'm looking for milk. Well, milk is in aisle 17. And on the way, you might want to see the sale in Hershey bars.
Yeah, for samples here on the left and.
Plus, you get to sit there and smell the baked bread from Subway all day long. So again, consider this. If you don't succeed at Walmart, then of course you only have one person to blame, and that would be your geometry teacher. Okay? So, we could stay with Mason's idea of doing 1/2 base times height, which would eventually get us there. It's just a lot more work. In this case, if we just use my fancy-dancy formula, we end up with that ugliness. Now, I know you're saying to yourself, Self, that's not better. Yes, it is. Because if you went and did base times height and had to calculate the height using Pythagorean theorem or 30, 60, 90 triangles or right triangle trig, you would want to cry and drop the class. So, if you don't have that written down, write it down for the area of an equilateral triangle. That is something, it's not obscure, but that's something that I don't know if, let's say, the AP test or even like the SAT would provide for you. They're going to give you area of a triangle is 1/2 base times height, but I mean that's big kid stuff right there. So that monstrosity is the area of that triangle. I've pretty much done the hard work. The question is, and the only question I have to answer now is, I'm taking rectangles from where to where? In other words, when I set up my integral, and that would be the integral of that mess over there, a of y, where am I taking rectangles from and to? Go, Kate.
-4 to 4?
Say again?
-4 to 4.
-4 to 4. Is there another way you could do that?
-8 to 0. You could just multiply it 2 in the front, go 0 to 4.
You could go
Or
0 to
-4.
4 and double it.
Yeah. Or
Right? Now, why would you do that? Why not just go -4 to 4? The only reason I would say you might want to do 0 to 4 and double it is because a lot of times when you plug 0 into a function or an antiderivative, it's easier to work with. Okay? Just throwing it out there, you don't have to do that. If you simplify that area, it comes out to be something fairly reasonable, which you can then create that integral. -4 to 4, and move the square root of 3 out in front because it's a constant. And then just went and solved that bad boy. Now, you would probably FN int this. It wouldn't be bad to practice it. But eventually, you're going to get down to that, 147.802. Accurate to 3 decimal places. So again, your goal is to find the area of the shape. And it would be nice if the problem said equilateral triangles and you could just do the equilateral triangle business. But that formula for the equilateral triangle will change based on the shape that you stand it up on top of. If we did, for instance, the parabola from the previous problem, your bases would be different. So imagine if we were using this problem, this example, and instead of standing it on a parabola, I stood it on top, instead of using a rectangle, I used an equilateral triangle. You would then use 2 square roots of x into the formula for an area of a triangle. Okay, so you're going to play with 2 different things, changing the base and changing the shape that's standing up on top of it. Most of the time, if not all the time, the thing that you stand up on top of it will be a nice simple geometric shape. Okay, a semicircle, a triangle, a rectangle, a square, maybe a trapezoid, I don't know. We'll see. We're done. Well, why did I include that Millennium Falcon?
Whoa.
It's a cross section of the Millennium Falcon.
Oh.
Wow, I do not think I've ever heard a more condescending "oh" than I just heard from about 8 of you. That's it, fine. You know, I'm just going to leave a blank screen on the end then. You guys can go get. No. You had your chance. You had your chance. You're done. You're done. I'm not going to share with you the kitty picture that I had ready to go or the little puppy picture. No, we're done. We're done. We're done. We're just going to put a plain old boring white screen that says day 65 and